The cosmological constant. Evidence of purposeful fine-tuning for life. The cosmological constant, lambda, is one of the most perplexing and finely tuned parameters in modern physics. Its precise value controls the large-scale dynamics of the universe, particularly the rate of its expansion. For life to exist, the cosmological constant must be balanced within an extraordinarily narrow range, no higher by more than 1 part in 10 to the power of 120, and no lower by the same margin. This tight specification is crucial for the formation of stars, galaxies, and planets, which are the building blocks of complex life. The delicate balance of lambda points to an intelligent and purposeful design of the universe, as the probability of this fine-tuning occurring by random chance or natural law alone is vanishingly small. In this article, we will examine the scientific basis of this claim and argue that the precise value of lambda is a strong indication of intelligent fine-tuning. The role of the cosmological constant in the universe. The cosmological constant is a term that appears in Einstein's equations of general relativity. It represents the energy density of the vacuum, also known as dark energy, which permeates all of space and drives the accelerated expansion of the universe. The value of lambda determines how quickly the universe expands. A larger lambda leads to faster expansion, while a smaller lambda allows gravitational forces to dominate, potentially leading to a collapse of the universe. In the early universe, matter and radiation were the dominant forces shaping cosmic evolution. However, as the universe expanded and matter became more diffuse, the cosmological constant began to dominate the dynamics of the universe. Today, dark energy accounts for about 68% of the universe's total energy density, and lambda controls the expansion rate on cosmic scales. The necessity of fine-tuning for life. For life to exist, the universe must have a structure that allows the formation of stars, galaxies, and planets. These structures form through the process of gravitational collapse, where regions of higher matter density pull in surrounding matter, leading to the formation of galaxies and stars. However, for this process to occur, the expansion rate of the universe must not be too rapid, or else matter would be spread too thinly to clump together under gravity. At the same time, if the universe expanded too slowly, or if gravity dominated completely, the universe would collapse into a big crunch before stars and planets could form. The cosmological constant plays a critical role in maintaining this balance. If lambda were even slightly larger, the universe would expand too quickly, and no galaxies or stars could form. Observations and calculations show that an increase in lambda by just 1 part in 10 to the power of 120 would lead to a universe where matter never has the opportunity to clump together, as the repulsive force of dark energy would dominate too early. This would result in a universe with no structure, no stars, and certainly no life. Conversely, if lambda were even slightly smaller, the universe would eventually stop expanding and begin to contract. The gravitational pull of matter would overcome the expansion driven by lambda, and the universe would collapse into a big crunch. Such a universe would end long before galaxies, stars, or planets could form, making it impossible for life to exist. In either case, the possibility of life hinges on an incredibly fine balance. The improbability of random or naturalistic origins. The degree of fine-tuning required for the cosmological constant is staggering. The precision required, 1 part in 10 to the power of 120, is so extreme that it defies any explanation rooted in natural law or random chance. To put this in perspective, this level of precision is like aiming to hit a target less than a millimeter wide on the other side of the observable universe, over 46 billion light-years away. The notion that such a fine-tuned value could arise randomly is mathematically improbable, bordering on the impossible. Natural law? One possible explanation for the fine-tuning of lambda is that it arises from an as yet undiscovered natural law. However, current theories of physics, including general relativity and quantum field theory, provide no mechanism for determining the value of lambda. In fact, early attempts to calculate the cosmological constant from quantum theory resulted in predictions that were off by a factor of 10 to the power of 120, far too large to correspond to the observed value. This discrepancy, known as the cosmological constant problem, underscores how poorly understood lambda is from a theoretical standpoint. If natural law alone determined the value of lambda, we would expect a much larger or more random value, not the precise value we observe. The fact that no known laws predict this value suggests that something beyond natural processes is at work. Random chance? The alternative explanation, that the value of lambda arose purely by chance, is even more implausible. The probability of randomly arriving at a life-permitting value for lambda is so small that it is virtually indistinguishable from zero. This improbability shows that the universe is not a random occurrence, but rather the product of careful calibration. To argue that the cosmological constant's value was set by random chance would be to argue against all statistical reasoning. When faced with such extreme improbabilities, scientists and philosophers alike seek deeper explanations. If a dice were rolled and it landed on an astronomically unlikely number, we would not assume it was pure luck. We would suspect that something more purposeful was at play. The same reasoning applies to the cosmological constant. The case for intelligent fine-tuning. Given the extreme precision required for the cosmological constant to allow for a life-permitting universe, the most rational conclusion is that this parameter was intentionally fine-tuned. Such fine-tuning suggests a mind or intelligence behind the universe's design, one that purposefully set the cosmological constant to enable the emergence of life. This conclusion is supported by the fact that fine-tuning is a hallmark of purposeful action. When we see systems that are precisely calibrated for a specific outcome, such as a watch, a computer, or a telescope, we naturally infer that an intelligent agent designed them with a purpose in mind. In the case of the cosmological constant, the purpose seems to be the creation of a universe capable of supporting life. The cosmological constant is one of many examples of fine-tuning in the universe. Other parameters, such as the strength of the gravitational force, the masses of elementary particles, and the electromagnetic force, also appear to be finely tuned for life. Together, these examples provide compelling evidence for intelligent design. Conclusion: the cosmological constant and the fingerprint of purpose. The cosmological constant is finely tuned to an extraordinary degree, and this fine-tuning is necessary for the existence of a life-permitting universe. The probability of this value arising by chance is vanishingly small, and no natural law has been discovered that could account for such precision. The most reasonable conclusion, therefore, is that the cosmological constant was intelligently and purposefully set to allow for the existence of life. This fine-tuning provides strong evidence for the existence of an intelligent mind behind the cosmos, one that calibrated the universe with life in mind. The cosmological constant stands as a profound indication of purposeful design in the fabric of reality. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.